Hello and welcome. We will take up some practice resonance structures. We'll draw resonance structures following the four basic patterns. Pattern 1, allyl carbocation, that is positive charge next to a double bond. Pattern 2, two different atoms, pi bond between two different atoms. Pattern 3, positive charge next to a heteroatom with a lone pair. Pattern 4, and these first three are one arrow mark, one arrow pattern. And pattern 4 is two arrow mark pattern. That is allylic or allylic-like lone pair. And also we have seen conjugated double bonds, carbonyl compound with alpha beta unsaturation can be treated like a pattern 4 with two continuous arrow marks rather than following pattern 2 first followed by pattern 1 that we should do. I recommend that for alpha beta unsaturated carbonyl compound you must first go for pattern 2 1 arrow mark, then pattern 1 allylic carbocation. Let us start. We'll be taking up some of the practice structures, writing their resonance structures. And in this video, I will be doing a select few, maybe 2 or 3 in a particular page. Now in this page, you find that this looks like an allylic carbocation. Looks like it's nitrogen, not carbon, but it looks like that this pi bond can be delocalized, but no. If you do so, then nitrogen will violate the octet. It will exceed 8 electrons. So this is not a valid resonance structure. I told you the rules that you cannot exceed octet for second period elements, nitrogen, oxygen, fluorine, carbon, cannot. But this one is a acceptable valid RS because this is an allylic pattern 1, so this pi electron can shift. This is again invalid because if you shift this pi electron and make a double bond here with a plus charge here, then this oxygen will violate octet. It will exceed octet. So this is not a valid RS. But this is pattern 3, that is positive charge next to a lone pair, and this is a valid because no one is violating octet, right? Exceeding octet. Of course, this is violating octet. Carbon is a sextate here. It is violating octet but not exceeding octet. That rule is violated. It exceeds octet here, this one, and exceeds octet here. Now let's see. This is again invalid because if you shift this having no plus charge here, then again this will be carrying more than octet because there is a lone pair. 2 plus 2 plus 2, 6 plus, there are 2 more hydrogen atoms. So it is already octet and it will be accommodating 2 more, 10. It's not possible. Right? Similarly, the breaking of this sigma bond to give another RS is absolutely unacceptable. Why? Because sigma bond doesn't break here, doesn't delocalize in resonance. It is the pi bond, the pi electron, the p orbital, they go for delocalization. Draw the RSS and indicate the pattern. We'll be doing together. Remember that you are having a pen and paper with you, pausing, doing of your own, then checking with me, then only you grow and really benefit from our program. Now see, this you have to apply, I told you, the first 3 patterns with 1 arrow mark. If you fail to get such 1 arrow mark pattern, then go for 2 arrow mark pattern. Now here, this is pattern 2. Pi bond in between 2 different atoms. So pattern through, simply the electron pair will be delocalized to the more electronegative element, so that there will be 2 lone pairs. Now the positive charge will be neutralized and a new positive charge will be created here, because this carbon is the loser, oxygen is the gainer, and the plus charge is neutralized, a new plus charge is coming to the carbon. There is always a conservation of charge. Pattern through. And if you want to convert this RS to this RS, then you have to use pattern 3, that is positive charge next to a lone pair. Let us go to the next one. Now see, we fail to apply pattern 1, 2 and 3. We look for an allylic lone pair. This lone pair next to a pi bond. It's a conjugated system. So 2 arrow pattern will be used, pattern 4. This will come here, this will come to this place. So don't change the atomic skeleton. In drawing the resonance structures, you have to copy the same atomic skeleton, but only the pi electron, non-bonding electron, pi electron system distribution will be changed. Now nitrogen will carry a plus charge, it is the donor. This will become a double bond, this will become a single bond, and a lone pair will come here with a negative charge. Now if you want to convert this into this, again the opposite allylic lone pair. This will come here and this will go there. So again a 2 arrow pattern will be used. Now coming to the next one, we also fail to get 1 arrow pattern. So a lone pair next to a pi bond, allylic lone pair, pattern 4 is applicable. So 1 lone pair will come here and this pi electron pair will come to this carbon. So you will have O, here double bond with 2 lone pairs, and here there is a lone pair and a minus charge. That's it. And to convert this into this, again 2 arrow pattern in the opposite direction. Allylic. Allylic like. This is allylic lone pair, but this is allylic like. This is C double bond O. Then there is a lone pair next to C double bond O. Or you can go for first pattern 2, polarizing this pi bond plus minus, then go for pattern 3. But that is invalid because so many charges, plus here, minus here, minus here, more than 2 charge centers make the particular RS invalid, insignificant. We will know about that in our next program. This is simply an addendum, a supplement to the video 4 speaking about the drawing of resonance structures. Going to the next one, I think I will select this, both. Why? Because this is an allylic lone pair, 2 arrow mark pattern, P4. P4. So there will be 2 arrows. So a lone pair and a negative charge will be here. This will be this is single bond. This will be double bond with no lone pair, no negative charge. Pattern 4. And this is allyl carbocation, pattern 1. So that the pi bond will delocalize, not the positive charge. Positive charge doesn't migrate. Indirectly it shifts its position, but it's the pi electron that migrates, that gets delocalized. You need not have to show every time the conversion of the second one to first one. Do not show that. Only the first. So put the arrow marks only in the first. Now tell me which pattern this is. The pattern is allylic like lone pair. Lone pair next to a pi bond. This lone pair, and this lone pair, they are not required in conjugation. So you apply P4 to use 2 arrow marks simultaneously to get the other 3 lone pairs with negative charge. This is double bond and O will be carrying plus charge and all other thing will remain the same. You could have also used pattern 2 first, polarizing this pi bond plus minus, then pattern 3 lone pair positive charge adjacent to each other, so that you will not get any invalid RS like the one we got before. There will be 3 charge centers. Here there will be only 2 charge centers. But even then, that one is a very less stable contributor. So I have recommended for allylic like lone pair, you can avoid using 2 successive 1 arrow mark patterns. Pattern 2, pattern 3. You avoid that. You can go for allylic like lone pair, 2 arrow mark pattern, so that you can get the 2 stable contributors. You can, yes, theoretically you are missing one. That is not an invalid RS if you use pattern. I am just saying, doing somewhere here. I don't have space. Let me create a space for you to show you that that can be done. Only when there will be more than 2 charge centers, you have to invalidate that. But if there will be maximum 2 charge centers, then it is a valid RS. About those things we shall discuss later. What I was saying about this one, as we know, you can first apply pattern 2. You don't write in your practice, but since you are beginning, therefore I have asked you to write the patterns every time, which pattern you have used. So this becomes a polar with 3 lone pairs and minus charge, and this is plus charge. Then apply pattern 3, positive charge next to a heteroatom, so that you get the same one which you got by applying allylic lone pair, allylic like lone pair. Right? So you may not write this one. Straightway use 2 arrow marks, 2 arrow mark pattern. Because this one is less stable. It's not invalid, it is less stable. Now coming to the next one, I think the next one you will be, this one. This one you will be doing of your own and tally with my answer. that this is again allylic like lone pair, allylic like. But you cannot use pattern 2 followed by pattern 3, because if you do so, then plus minus there will be 3 charge centers, already a minus charge. So only pattern 4 can be used, not pattern 2 and 3 together. So this is allylic like lone pair, so that you get another RS where this carbon nitrogen now becomes single bond, and nitrogen gets one more lone pair with a negative charge, and this is a double bond, and there is no lone pair here, no charge here. The charge migrates to nitrogen, right? There is always a conservation of charge, remember that. Just I am separating, demarcating to avoid confusion. Got it? Had we used pattern 2, then this would have been plus and this is minus. So there is another minus here. So more than 2 charge centers makes the contributor invalid. Now let us go to the next one. Now tell me, for this one, you have to go for pattern 2, then followed by allylic carbocation pattern 1. Now I am telling you, it is always good to first use one arrow mark, because you can see that this becomes polar with plus minus, and there is now an allylic. This is pattern 2, then pattern 1, allylic carbocation, so that you get this a double bond and this a plus charge, CH2 plus. Supposing this is CH2, CH2, this is plus. Now if you use 2 arrow mark pattern analogous to pattern 4. Pattern 4, the name was allylic or allylic like lone pair. It's not allylic. 2 double bonds in conjugation. And this is an electron withdrawing group. So the direction of electron flow, electron delocalization is towards oxygen. Therefore, the other alternative method that you get is by using pattern similar to pattern 4. 2 arrow mark, I call it pattern 4. But the exact title of pattern 4 was allylic or allylic like lone pair. It's not like that. So you can use that. You delocalize this pi electron to the adjacent position and then delocalize the pi bond to oxygen, so that you get the same one, the third one that we got in our previous discussion. And this is single bond and this is plus charge, the same one. But this you have to draw. Often students, they bypass this, but I urge you to draw, particularly in this case when you will not find that the number of charge centers is not exceeding 2, it is remaining 2, within 2 or less, then you have to do, so that in the hybrid structure, you can dare say that in the entire conjugated there is a minus delta here, plus delta here also, and plus delta here also, because plus is here, plus delta, plus is here, plus delta. But if you write like this, you will have no authority to put a plus in this. You put a dotted line, that's okay. That is the bond, is the average. You put a dotted line, it's okay. But you give minus delta here, plus delta here, plus delta, plus delta, minus delta. So no plus delta here at this carbon. But this carbon has some electrophilicity. Yes, I don't say that this carbon is Also, I say that this carbon is also electrophilic, but this carbon is also electrophilic. So it is really, really good to write systematically without, bringing more than two charge centers. There is, of course, this is less stable, carbocation, but this is also a carbocation. This is less stable, so this can also be less stable. This is a carbocation. So, okay, so in this case, you apply 2 times pattern 2 followed by pattern 1. And this one you do at your home independently, because this is not a conjugate, this part is not in conjugation. Only it is allylic like lone pair, this lone pair and this pi bond. This lone pair and this pi bond, they are in conjugation. So one lone pair will come here, this will go. So this will be, single bond with 3 lone pairs minus charge, this will be double bond. This plus will remain as such. This is a nitro group. This is a additive bond. In this question number 3, I have asked you to give arrow marks and lone pairs. I have not given any lone pairs. You have to first assign the required number of lone pairs, then give arrow marks to show the conversion of this RS to the other RS, this RS to the other RS. It is very simple. Now oxygen has 2 lone pairs, and arrow mark is, this is pattern 2. You got this? And there will be 3 lone pairs now, and to convert 2 to 1 you have to use pattern 3. Now there are 2 lone pairs here, and I told you that you have to write 3 RSS, this another 2, but since I have bypassed the second one, I have given only the third one, therefore you need not bother. According to what I have given, you will show 3 lone pairs with a negative charge and everything is in order. And arrow mark like this, 2 arrow mark pattern 4. Similar to pattern 4, 2 arrow mark is either pattern 4 or similar to pattern 4. So this is, nitrogen has a lone pair of its own from birth, and there is another minus charge, means another lone pair is there. And oxygen has 2 lone pairs from birth, and with converting this you have to use the allylic like lone pair. So this has come here, so this has been transferred to oxygen, so that now the oxygen will carry 3 lone pairs and a negative charge. 3 lone pairs and a negative charge, and this negative charge will be discharged with 1 lone pair, the birth lone pair, and there will be a negative charge here. This is single bond, this is double bond. Similarly, this is an allylic carbocation pattern 1. This is pattern 1. This is, we have used pattern 4. We could have used pattern 2, but this is invalid. Plus minus, again minus. So again that we can't do. Now this is pattern 1. So there is no lone pair anywhere. So pi bond will migrate. So that's okay. Then coming to draw RSS and indicate pattern. So tell me, you do at home lone pair adjacent to a pi bond, in conjugation with a pi bond, allylic lone pair. So you cannot polarize this. Pattern 2 is not applicable to identical atoms, to different atoms, pi bond between 2 different atoms. So you use pattern 4 to draw the other RS. You draw up your own. This will be a double bond with 1 lone pair and a plus charge because it is the donor, and this is the acceptor, 1 lone pair with a minus charge. And to convert this into that, the other allylic lone pair in a reverse direction you have to apply. But I recommend not to use the arrow marks to show conversion from second to first, only from first to second. Now this is again allylic lone pair. This lone pair has nothing to do. It is not in conjugation. This doesn't take part. But this lone pair adjacent to a pi bond constitutes a conjugated system. So you draw of your own and tally with the answer I will provide. Again, this is allylic. You can here use pattern 2 and then pattern 3 because only 2 charge centers will come, or pattern 4 directly. Plus charge will come here, 3 lone pairs with a negative charge will come here. Now, place the lone pairs and write RSS. Let us take up one in details. Oxygen from Barth, 2 lone pairs, and there is no charge, here also 2 lone pairs. So what pattern you will be using? You can use pattern 2 followed by pattern 3. It is okay. But you can directly use pattern 4. This will come here, this will come here, so that you have 3 lone pairs, and this O will have 1 lone pair and a plus charge. There is a double bond here. This is single bond, this is double bond with 1 lone pair. Right? Yes, I told you that you could have used pattern 2 to polarize this pi bond plus minus, and then pattern 3 you could have got another valid RS. Now the minus charge means it is a lone pair, right? So this is allylic lone pair. So you write another lone pair with a minus charge will come, double bond will come here. And here the oxygen has 2 lone pairs, and it is again allylic lone pair. So a lone pair and a minus charge will come here, and O will carry plus charge because it is the donor. A lone pair with a negative charge, double bond will be here. Oxygen will having a single lone pair with a plus charge. Similarly, you apply, there is one lone pair, this is an allylic lone pair. You do of your own and tally. And this again, there will be 3 lone pairs. Minus charge means 3 lone pairs on oxygen. So this is again allylic lone pair. You write of your own. The negative charge will vanish from here, and a lone pair with a negative charge will come here. And in this case, this pi bond is not in conjugation with this lone pair, because this lone pair and this pi bond, they are away from each other by 2 sigma bonds, 2 single bonds, so they cannot conjugate, but only conjugation lies here. This is an allylic lone pair, pi bond next to a lone pair next to a pi bond. You could first apply pattern 2 to polarize plus minus, then pattern 3, but I am avoiding that to save time using pattern 4, 2 electron. This will be 3 lone pairs with a minus charge. This will be a double bond OH with 1 lone pair and plus charge. Others will remain as such, because this pi bond and this lone pair, they are miles away from each other. So there is no scope for any overlapping. So no resonance operating here. Now coming to the next one, you can draw up your own. This is a allylic pattern. This is extended conjugation, allylic pattern, pattern 1 2 times. First you look to pattern 1 and get the other RS. Double bond comes here, positive charge neutralized, new plus charge comes here. Then you see another allylic pattern. So this is pattern 1, this is pattern 1 extended conjugation. And this will come here, so that plus charge will come here. Similarly, this lone pair and this pi bond are constituting a allylic lone pair conjugation. This one of the lone pairs, pi bond, they are conjugated. So let us start. There is no one arrow mark pattern visible. So we have to be happy with 2 arrow mark. So this is extended, this is P4 extended conjugation. So first we whistle from here and this pi bond will come to the ortho position. And there is a double bond. Oxygen will have now 1 lone pair with CH3 and plus charge because it's the donor, and a new lone pair will come here with a negative charge, and others will remain the same. Now we discover another allylic lone pair. So again 2 arrow mark, curved arrow mark pattern will be used to get the other RS. So that lone pair will be here and other features will remain intact. And we see another allylic lone pair. So we write like this. A lone pair comes here with a negative charge and other features will remain the same. And double bond will be here and double bond was already there. And then the fifth one you are not supposed to count, but you practice. In your copy you practice. So this lone pair will come here and this pi bond will break, it come here. So the original aromatic structure is established. This becomes single with 2 lone pairs and there is no charge. So this is not counted. 4 because the number of conjugating units is 4, 1 of the lone pairs and 3 bond pair, pi bond pairs. 3 plus 1, 4, 1, 2, 3, 4. The original structure and the other charged structures. 1, 2, 3, 4. This is not counted because this is these two. This is another additional resonance structure of benzene ring, not methoxybenzene or anisole. You understood? Now this is simply pattern 1. You draw the other one. Positive charge will come here and double bond will come here. Now place the lone pairs and draw RSS. 2 lone pairs. So this is pattern 3. A positive charge next to a heteroatom. It's if you practice a bit, it will be visible to you. Once you see a structure, the lone pairs are given. In most of the questions, lone pairs are given. If not, you are asked to place lone pairs, then you have to use your knowledge. How many lone pairs are there in an atom in a neutral state? Then if there is already a plus charge or minus charge, then how many now present? So we have to use your. Now this will carry 1 lone pair and a plus charge. Double bond will be here and then everything else will be there. Then this is also the same. You do of your own. Pattern 3. This is also pattern 3, double bond. This will become double bond. This plus charge will vanish. Nitrogen will carry plus charge. This is again, there is minus charge on oxygen. Nitrogen means there are 2 lone pairs. One birth and the other acquired. So the pattern, this is again pattern 3. A lone pair next to a positive charge. So you write down where you will find there will be double bond here, plus charge will be discharged and the negative charge will also be discharged. And there will be 1 lone pair. That means to convert this into this, we have used pattern 2. Like this. So that there will be 2 lone pairs, negative charge and carbon plus charge. And we have to convert this to this means we have to use pattern 3. So, similarly, I just tell you to save time, this is 1 lone pair, so this is again pattern 2. Pi bond between 2 atoms. This is again pattern 2. Pi bond between 2. And this is pattern 2 followed by pattern 1. This becomes O with 3 lone pairs, negative charge, and this carbon plus charge, then you find allylic like pattern. And later on you find this particular part that is aromatic. You will know from Haeckel's rule of aromaticity, the cyclopropanedium ion is aromatic. But the resonance structures that you may write is, this is allylic pattern, it can come here and plus charge will come here. Again, it can come here, the plus charge can come here. And the other feature will remain this same. So that in the hybrid, plus delta will be on all the three, here, here and here. In all the three, as well as this is the hybrid structure. I have asked you not to write hybrid structure every time, but at your requirement, you can visualize the hybrid structure by putting dotted line, and then wherever there is plus charge, you have to make plus delta. And wherever there is minus charge, you will have to write minus delta. Right? Pattern 2 followed by pattern 1. Pattern 2, this one. Pattern 2 followed by pattern 1. Then this one is allylic, allylic unpaired electron. Free radical is same as allylic, is similar to allylic carbocation, electron deficient. So the one electron phi-Suc arrow mark will be used. One arrow mark, but phi-Suc. So that this dot and this dot will form a double bond. Double bond here, and the new dot unpaired electron will come to this position. A single phi-Suc arrow will do everything, will make your understanding very, very clear. So the other unpaired electron will come to this position. This unpaired electron and this unpaired electron will form a pi bond, double bond. And this is already there. Again there is an allylic radical. So again there is a one electron shift. To finally get the radical at this extreme carbon, there is a double bond here and double bond here. Got it? So this is pattern 1 repeated, extended 2 times. Extended conjugation. Now we will be selectively answering. Now I will be telling you that you look to the allylic lone pair. First get this plus and this minus with a lone pair. Again another allylic lone pair, so you will have 3. First start from the first allylic lone pair, plus charge with one lone pair, and this double bond will be now here, and again you find another allylic lone pair, so this will come here, this will go here, and all other things will remain the same, and a new lone pair will come over here with a negative charge. Understood? Similarly, one lone pair is here, so either you can go for pattern 2, first polarizing this triple bond, converting double bond and plus minus, and then allylic carbocation, or you can use pattern similar to pattern 4 with 2 arrow marks, so that you can get the other one, CH2, single bond CH, double bond C, double bond N with 2 lone pairs, negative charge, and this will carry, this is the ultimate loser, so this positive charge, and that's okay. Now tell me what you will do for this 2 lone pairs. So you have to go for pattern 2 with plus minus, then pattern 1. You do of your own. And in this structure, or you can bypass. you can use pattern 4, similar to pattern 4, 2 arrow mark like this, to bypass the middle one, the second one. You can do that, but I advise you to go for, in this case, you go for all the 3. Pattern 2 followed by pattern 1, allylic carbocation. Now here there is no conjugating unit in this part. There is nothing, only, pattern 2 is applicable at this portion. There is nowhere. Carbon-carbon double bond cannot be polarized, only when there are 2 different atoms. So you can draw plus here and 3 lone pairs with a minus here. Now there will be 3 lone pairs. 3 lone pairs, minus charge means 3 lone pairs, here 2 lone pairs. So you immediately discover there is no 1 arrow mark patterns. You just look to the structure. You find the first allylic lone pair is here. The allylic lone pair, this lone pair and this pi bond, they are in conjugation. So start from there. So you will get the other one. Again another allylic lone pair, this will be double bond with 2 lone pairs. And here there will be negative charge. Again another allylic pattern will be visible to you. Of course, aldehyde will remain as such. Another, oh, I'm so sorry. Then another allylic pattern is visible to you. So go for that. Bring the lone pair and negative charge to this. And other things will remain the same. Double bond here, and of course C double bond OH is there. And a lone pair and negative charge is here. Then another allylic lone pair, allylic like lone pair is visible. So you go for that. You cannot use a pattern 2 here because there will be too many charges. So allylic lone pair pattern will be used here. Will be used here to go for this one, where this is a double bond, this is a single bond with 3 lone pairs and a negative charge, and all other features will remain as such. And then you can use allylic lone pair to get back this one. So to avoid that, I told you that you go for 3 arrow mark pattern to bypass the repetition. You bring this to this position and this to this position. You know that. We have done in nitrophenol or something like that. So we get a negative charge at this position and double bond here, single bond here, and as usual this double bond aldehyde double bond with 2 lone pairs will be here, and other features will remain intact. Had we used allylic 2 arrow mark pattern, then the lone pair and negative charge would have come here, same as this. So why to? You can't count that. The same one cannot be counted 2 times. So why to write? Therefore, to avoid that, I use the next step. That means from this you have to use 3 arrow marks to arrive at a new RS, and then need not have to write again an allylic like lone pair to get back to the original benzene RS. You may not write that, but I urge upon you to practice. That also. It's not counted. I'm writing CHO, and this as usual O minus, phenoxide ion. It's not phenol, it is phenoxide ion, right? Now here, this will be a extended conjugation. You find these are 2 lone pairs and this pi bond in conjugation, but truly you must show pattern 2 to make it plus minus, then allylic carbocation pattern 1, but I am just avoiding delay, so I am going for a 2 arrow mark pattern to bypass one RS. Should not have done, but I don't have time. So I have bypassed pattern 2. Rather, I am using pattern 4 like arrow mark, 2 arrow mark pattern. So that double bond will be here and plus charge will be here. Then once you have, this is a benzylic carbocation. This pi bond is next to a positive charge, allylic carbocation. So pattern 1 is visible. Then you continue to apply pattern 1 and this will come here and the other features will remain the same without any change, and you find a plus charge is now here. Again another allylic carbocation is visible, pattern 1. So this first one is this is pattern 4, similar to pattern 4 I have used by passing pattern 2, pattern 1, then pattern 1, then another pattern 1, so that I will get a plus charge here and double bond here, and all other features will remain intact. And here also will remain intact, right? Another allyl carbocation is visible, so that you get another RS where plus charge will be here and double bond will be here, and the double bond was already here, and the other three features will remain the same. And then to get back to the original benzene ring, you have to go in opposite direction. This will come here, you know, and then I think I have left a double bond here. I'm so sorry. This. So the lone pair will come here, make carbon oxygen double bond. This double bond will be here. I mean pi bond will shift, and this will come here, so that the original benzene ring, of course with inverted pi double bond single bond, but benzene ring will be revived with the original structure. Got it? You have to make practice. I told you to pause my video, practice and tally. Don't be silly. You know, you can bypass a lone pair. Okay, one lone pair is missing means nothing will happen. No, you must be very serious. You cannot miss any lone pair or a charge plus or minus. If it is there, you cannot miss that. Then you are not an expert. You can be expert by a small practice. Some practice will make you perfect. Now see, I told you to avoid delay. So there is a lone pair here, two lone pairs here. So this lone pair and this pi bond constitutes an allylic lone pair, and you go for a 2 arrow mark, then minus charge will come here with a lone pair, another allylic lone pair, and the minus charge will come here, another allylic lone pair, minus charge will come here, then back to pavilion. This pi bond will break. But there will be another conjugation. You have to show in other side that with a different colored pen or pencil, you show the conjugation here. This is allylic lone pair next to a pi bond. So this and this 2 arrow mark, so that double bond plus charge and O minus charge single bond will be there. So for benzene 4, and on this side there will be another 1. So altogether we have 5. Because the number of conjugating units is a pi bond here, 1, 2, 3, 4, 5. So there will be 5. Minimum number of RSS will be 5. But we can also polarize this one, pattern 2 plus minus, then pattern 3 to increase the number of RSS to 6. Usually we avoid that, particularly in allylic like lone pairs. You can write down of your own and tally with the answer. Now there are 2 lone pairs. This is allylic lone pair. This lone pair and this pi bond, they constitutes a conjugated system. So this will come here You can also use pattern 2 followed by pattern 3. So here also you have allylic lone pair. This lone pair and this pi bond are in conjugation. These two lone pairs have no role to play. So you can use either plus minus pattern 2, pattern 3, or similar to pattern 4, you can write down. But that one is a valid one because there is only 2 charge centers, not 3. So you can also write that, but often we do not write for allylic like lone pair, we do not write. Similarly, there is a lone pair here, but here we have to go for pattern 2. You have to go for pattern 2. 2 different atoms. There is no allylic like lone pair. Had there be a single bond here, double bond here, then allylic like lone pair. But here, this is pattern 2. Polarizing this one, you get 2 lone pairs with negative charge, and plus charge will come here. Again, this is pattern 2, and then pattern 1. Because allylic carbocation is now visible to us, then you go for pattern 1 and everything else remaining same. Got it? Similarly, you can use this one. There is a lone pair. I have deliberately not given the lone pair. Now you look allylic lone pair. Again it comes here, another allylic lone pair. So go for 2 allylic pattern 4 2 times repeated or extended conjugation. And here there are 2 lone pairs. Minus charge means Barth lone pair and acquired lone pair. Then it is an allylic pattern, no doubt about it. So you have minus charge here, double bond here, and nitrogen will still have a lone pair but no charge. Now a lone pair, 2 lone pairs and 1 lone pair. So this is allylic lone pair. So you can use this and draw the structure. Or you can first use pattern 2 plus minus and then pattern 3. You can do that. Now these are very simple. I'll tell you, you will do at your home. This is allylic lone pair. Or you cannot go for plus minus pattern 2 because there will be 3 charge centers. No. Directly 2 arrow mark pattern. Here also you cannot polarize plus minus minus, so 3 charge centers. So you have to use as a lone pair is not shown. You have to show that, and then you have to use for allylic lone pair, allylic like lone pair. And here this is pattern 4 and this is I am using pattern 4, but here no you cannot use pattern 2 followed by pattern 3, no, because the middle one will have 3 charge centers in these 2 cases. You cannot. In other cases we were just not doing because we were lazy, or we know that middle one is maybe a little less stable, but no, sometimes it is equally stable as the other one. So you should not. Now this is pattern 1 repeated, extended. Plus charge will come here, again pattern 1. And here lone pair, 2 lone pairs, and this is pattern 3. You write down. You have to write down and tally. And here there is 1 lone pair, but that lone pair is not at all taking any part. This is simply pattern 1. This lone pair has no role to play. And here there is a lone pair, minus charge means lone pair, and this is allylic lone pair. So start your journey. Another allylic lone pair will come, and again a lone pair will come here. Another allylic lone pair will come. So you will have how many? 1, 2, 3, 4 conjugating units, means 4 resonance structures. Here there is a lone pair and a positive charge, so pattern 3 is applicable. You can use. And here there are 2 lone pairs, 1 lone pair. So pattern 3 is available on either side, this side, that side. But logically oxygen is a smaller size than nitrogen. Let us take this side. So first apply pattern 3 to get a double bond here, OH, and one lone pair with a plus sign and NH. Then immediately pattern 4 is visible, allylic like lone pair next to a pi bond. So pattern 4 is applied so that you get this 2 lone pairs with no charge, a double bond here, and nitrogen will now carry the plus charge. Same thing would have happened if you would have applied pattern 3 towards nitrogen and then pattern 4 from oxygen lone pair enjoying the allylic lone pair. Right. We are almost at the end of our program, and I will not further delay this 2 lone pairs. You first look to one. Now you cannot say that let me go for 2 arrow pattern. This is an allylic lone pair. No. Since one arrow pattern is there, you cannot use 2 arrow pattern by rule. So you do that, get +1 and then pattern 3. So pattern 1 followed by pattern 3. You do it. And here plus charge is there, allylic carbocation, and this will come, so that plus charge will come here, another allylic carbocation pattern 1, so pattern 1 repeated 3 times. And there are 2 lone pairs, and this is an allylic lone pair, so one lone pair will come here, and this will go, and this will be, O will be carrying one more only one lone pair with a plus charge, double bond here, and a negative charge will be at this carbon. Now this one, 2 lone pairs, pattern 3. This is pattern 4. This is pattern 3. You can write down double bond, O will now carry plus charge. Now again, this is pattern 1. You know, pi bond will migrate, not the positive charge. Now the new pi bond, plus charge center will be here. There is double bond here. And this one is pattern 2. You know, pi bond between 2 different atoms, the lone pair has no role to play. Plus charge will be here, and minus charge with the 2 lone pairs will be in the other RS. And this is, we have already done, nitrogen has 1 lone pair. This is allylic system. So first 2 a curved arrow mark, this is P analogous to P. Why analogous to? It is P pattern 4, allylic lone pair. So minus charge will come here, again allylic pattern. Minus charge will come here, another allylic pattern, so that you come back to pavilion. So we have done this in our previous video, so you practice. Now there are 3 lone pairs here. This is an allylic pattern, so that you get the negative charge will be on this one. There will be 2 lone pairs, and negative charge will be on this carbon, and other will remain intact. Another allylic lone pair pattern is coming, so that you apply 2 curved arrow marks. So negative charge is coming here with a lone pair, and here, and all other things will remain as such. Double bond is coming here. Then another allylic lone pair come here, and this goes there, so that you let us write like this. This minus with a lone pair, and there is a double bond here, already double bond there, and then double bond here with 2 lone pairs. Got it? Now, is it not really interesting that if you make a bit of practice with a focus, that you will not lose a lone pair, not miss out a positive charge, or add an extra lone pair, then you will be an expert in the field of resonance and hence organic chemistry, because the spinal cord of organic chemistry is resonance. Now we are almost at the end of our program. This I am showing you, there are 2 lone pairs. This is acetophenone. So we first start with this pi bond and this pi bond are in resonance, in conjugation. Or we can apply pattern 2 first, which often you will not find in any book because there is no, this is minus, this is plus. Then allylic carbocation pattern 1 is visible. Another plus charge will come, another allylic pattern will be visible. Then plus charge will come here, another. So 3 allylic patterns plus pattern 2. Pattern 1 is continued, or you can bypass, use 2 arrow mark pattern, pattern 4. So the total, if you bypass this one, then 1, 2, 3, 4. 4 RSS minimum. Therefore, the minimum number of resonance structures is the number of conjugating units. So there are 4 pi bonds, this pi bond, this pi bond, this pi bond, they are conjugating. But if you apply pattern 2 to polarize this one, you are getting an additional one, although it is less stable, but it's not invalid. There is only 2 charges, not 3. You understand? You do it. And here there are 2 lone pairs, 2 lone pairs. So these 2 lone pairs are of no use. I mean, they are not taking part. So this is an allylic lone pair, so allylic like. Or you can also polarize pattern 2 followed by pattern 3. That is acceptable. The middle one is not invalid, but you can use, allylic pattern 4 can be used to get the other one with a plus charge here and minus charge here. Now there is 2 lone pairs here. Now you cannot go for an allylic lone pair rather than allylic positive charge. One curved arrow mark is to be located first. So start here, plus charge will come here, again this will go here, plus charge will come here, then pattern 3. So pattern 1, then pattern 1 followed by pattern 3. So 1, 2, 3, 4. There will be 4 resonance structures including this one. Got it? You write up your own. Now there are 2 lone pairs here, and so you cannot start from here. It will be 2 curved arrow marks. You have to start from here. This is an allylic pattern. This will come here, plus charge will be here. Again this will come here, plus charge will be here. Again this will come here, plus charge will be here. Then pattern 3. So pattern 1, pattern 1, pattern 1, how many? This is 1, pattern 2, pattern 3, then pattern 3. So 1, 2, 3, 4, 5. There are 5 conjugating units. 1 positive charge, empty orbitals is 1, 2, 3, 4, 5. So 1, 2, 3, 4, the original is 1. 5 we will get. Right? So we come to the end of our program. There are 3 lone pairs, and you have to, there is no 1 arrow mark pattern here. You have to start with 2 arrow mark. Then minus will come here, again another allylic lone pair, minus charge will come here, another allylic lone pair. So 1, 2, 3, 4. So you have 4 RS. So pattern 4 is repeated, extended 3 times. So here in the last slide, I have shown you a female sex hormone estradiol, where in this part there is no conjugation. Only in the phenolic part there will be conjugation. You can draw like you were drawing for aniline and phenol. This is an allylic pattern, so you start doing that. Another allylic pattern, negative charge will come here, then another allylic pattern. So this is just like any other allylic pattern. But here in the male sex hormone testosterone, only the conjugating unit is present in this case, in this area. So either you can go for pattern 2 plus minus and then allylic pattern 1, it is better, so that this carbon will get plus delta in the hybrid, or you can go for a 2 arrow mark pattern similar to pattern 4 to get 1 more resonance structure. But in this case, I always advise to go for pattern 2 followed by pattern 1. That is the end of our program. So I made it a little longer so that my intention is for the generation to come. Students will immensely benefit from this practice session as well as the previous one. And in the next video, we will see the rules to know which RSS are more stable, which are less stable. That means the more stable RS will contribute more to the hybrid. The actual structure will resemble closer to the more stable RS. than the less stable RS. And which one is an invalid RS? As I was just sounding you in advance, there is 3 charge centers not acceptable. And many other rules will come up. Until then, bye bye. Take care.